Now, 12.5, we're going to talk about some properties of logarithms. What I mean with the properties is we're going to be able to condense, we're going to make it smaller. We're going to be able to expand, which means we're going to make it bigger. Now, one thing we have is, as long as I have a logarithm of a certain base, and I'm multiplying things there. Notice I have x times y, because two letters, when they're put together, means times. When there's a multiplication, I'm going to split it as an addition of two logarithms. Notice how I'm using the same base. So in multiplication, I'm going to split it. I'm going to expand it. We call this expanding. We're going to expand it. We're going to make it bigger as an addition of two logarithms. Examples: log base 3. Log base 3 of 4 times 7. I'm going to call this log base 3 of 4 plus log base 3 of 7. But then at the same time, though, what if I'm given the question with a plus in between, though? You must have the same base, though. Let me emphasize that. Let me say that log base 10 of 8 plus log base 10 of 9 is equal to log base 10 of 8 times 9. Notice how I can expand it. I can make it bigger. I can condense it, make it smaller. Now, if you call this log base 10 of 72, you're correct, because then you multiply 8 times 9. So you can condense it even more. All right, let's take a look at this. Use the product rule to rewrite each expression. So this one is given to me, and I see a multiplication. So I'm going to expand it. I'm going to make it bigger. I'm going to call this log base 5 of 6 plus log base 5 of 9. Do simplify each log if possible. You guys will see in a minute what I mean with that. Do simplify each logarithm if possible. In this case, we cannot. Like I said, you guys will see in a minute. Now, looking at example B, I see my plus in between, and I notice that I have the same base. So I'm going to condense this. I'm going to make it smaller. I'm going to call this log base 7 of 8 times 12. Right, my plus, I'm going to condense it as a times of 8 times 12. Now, I know 8 times 12 is 96, so I'm just going to call this log base 7 of 96. Now, looking at example C, 3x, isn't that 3 times x? So I'm given to this as a times, so I'm going to expand it. I'm going to call this log base 3 of 3 plus log base 3 of x. Remember, I said simplify each logarithm if possible. Looking at my first logarithm, I know I mentioned when these numbers, the base and that number repeat, didn't I just call that a special case, and didn't I just call that a 1? So I'm going to say here I have 1, the whole logarithm, log base 3 of 3, that's just 1, plus log base 3 of x. Now, for D, right, x to the third power, let me rewrite that as log base 4, in parentheses, let me do this as x times x times x, right? X to the third power is x times x times x. But look, I have it split in multiplication. I have two multiplications this time. So when I expand it, I'm going to have two pluses. So I'm just going to write this as log base 4 of x plus log base 4 of x plus log base 4 of x. Now, back in elementary, you guys were told that when you're adding and you're adding the same thing, look, I have log base 4 of x plus log base 4 of x plus log base 4 of x. When you're adding and it's the same thing, you keep on adding, isn't that the definition of multiplication? When you add the same thing over and over? In this case, I'm adding it 3 times. So I'm just going to condense this as 3 log base 4 of x. Now this one looks very, very similar to the beginning. When I had a 3 as an exponent, it came to the front. Keep that in mind. In a few slides, I'm going to talk about a rule. Okay, so this you guys can try it at home, and this is what you guys will be getting. Now, remember, multiplication, we split it as addition, right? That's what we just did. So now we're going to call this the quotient rule. Quotient means just a division, but on logarithms, if it's given to me as a division, right, x divided by y, I'm going to split it as a minus. So instead of times, remember multiplication, we split it as addition. Division, we split it as a subtraction. Now, for example, log base of 5 of 2/3. Isn't that 2 divided by 3? Right, 2/3 is 2 divided by 3. So log base 5 of 2 divided by 3, I'm going to call this as log base of 5, log base 5 of 2 minus log base 5 of 3. Right, our division, I split it as a minus. The same time, though, a minus of 2 logarithms, I can condense it and make it smaller as a fraction or as a division of 1 log. Now, one thing though, I cannot split. If I have a log and I have a plus in there, remember on the previous rule that we talked about is multiplication. One logarithm of multiplication, I can split it as an addition of 2 logarithms. Now, the sum in a logarithm, I cannot split it as the sum of 2 logarithms. Right? That one doesn't work. Right? These are things that people get confused. Don't do that. All right. So looking at quotient rule, the way I'm going to do this, I'm going to split this as log base 4 of 7 minus log base 4. Right. 7 over 9 is 7 divided by 9, and that I split it as a subtraction of 2 logarithms. Simplify each logarithm if possible. If possible. Now, example B, I'm given to this as a minus in between 2 logarithms. So in this case, I'm going to condense it. I'm going to say log base 5 of 6 divided by x. So I make it into a fraction, 6 divided by x. Looking at example C, is given to me as a division, right? A fraction is a division. So I'm going to split it as a subtraction of 2 logarithms. So I'm going to call this log base 3 of 27 minus log base 3, 5. Simplify each radical if possible. Now, log base 3 of 27, that is possible. Because I want you guys to see this as 3 to the x equals 27. Can you think of an exponent such that 3 to the x is equal to 27? Can we think of such x? 3 to the x. Can you think of an exponent such that 3 to the x is equal to 27? Yeah. I'm just going to call this 3 minus logarithm of base 3, 5. Right here, I cannot think of 3 to the x equals 5. I cannot simplify it. That's what I said earlier. Simplify each radical if possible. Now let's take a look at D. I see a minus between 2 logs. So I'm going to condense this as log base 6. It must be the same base of 28 over 7. 28 divided by 7. Now 28 divided by 7, I can simplify that. So I'm just going to call this log base 6 of 4. Right, 28 divided by 7 can be simplified by 4. Now I want you guys to try these at home. And that's what you guys will be getting. Now, few rules I want you guys to remember though. If x and b are positive real numbers, where b is not equal to 1, and if r is any real number, then the following holds true. Log base of x to the r is equal to r times logarithm of b, base b of x. What does this mean? Notice how my r, my exponent, it looks like it just goes to the front. My exponent is going to go to the front. There was one before that I gave you guys, and I said, think of that one, because that one's very interesting. I had something like log base 4 of x to the 3, and that became 3 log base 4 of x. I had that a few slides before. Now, what this rule is telling us is if we have an exponent, just bring it to the front. The exponent becomes a whole number at the front. For example, log base b of m to the 5. My 5 is going to become an exponent at the front. It's going to become a number at the front. So 5 logarithm base b of m. Looking at this other example, my 4, my exponent, is going to become a coefficient. It's going to become a whole number at the front. So that becomes 4 log base 3 of 5. All right, let's take a look at that in example. Use the power rule to rewrite each logarithm. My exponent is going to become a whole number at the front. So I'm just going to call this 2 logarithm base 5 of 4. Do simplify the logarithm if possible. My exponent of b is going to become a whole number at the front. So 5 logarithm base b of x. Now you might come and say, well, radicals, that's not an exponent. Yes, it is. Remember how I always said radicals is a fraction as exponent divided by root. So this thing, I'm looking at this as log base b of 7 to the 1/2. Remember my radical is written as exponent divided by root. Square root is the root 2. 7 is 7 to the 1. So notice how my fraction, I wrote it as exponent over root. All right, so I'm going to simplify this as 1/2 log base b of 7. For example D, let me rewrite this first as log base 2 of x to the 2/5. Remember, it is powered over root, so 2 over 5. So when I rewrite this, I'm going to call this 2 over 5 times logarithm base 2 of x. Now, for example E, to begin with, I can rewrite this as log base 3 of x to the negative 4. What is a negative exponent does? It does a fraction. So I'm rewriting this as log base 3 of x to the negative 4. So when I use the power rule, I'm going to write this as negative 4 log base 3 of x. Make sure you write everything as an exponent. If you have a root, your exponent is going to be a fraction. So if you have a radical, your exponent is going to be a fraction. If you have the exponent at the bottom, you have fractions, then your exponent is going to be negative. Now you try these, and that's what you guys should be getting. Now we're going to use a couple of rules. For b to the power log b of r, log base b of r, Notice how, let me emphasize, this B and this B repeat. When those happen to repeat, I'm just going to get this. And then when I have log base B of B to the R, let me emphasize, when these two repeat, I'm just going to get that. So let's take a look. Example A. Let me emphasize, this one and this one repeat. Log base 5 of 5 to the 4th. When those repeat, I'm just going to get 4. Answer here is just 4. You might say, well, in example B, the 3 and the 9 are not alike. Well, let me rewrite this as log base 3 of 3 to the 2nd. Notice I rewrote my 9 as 3 to the 2nd because I wanted these 3's to repeat. So based on our second rule, I'm just going to get 2. This answer is just 2. Looking on our first rule, notice how those 4 repeat. So my answer here is just 10. Based on the first rule, that's basically my B. See how those numbers repeat? My answer in this case is just square root of 2. So these are the special cases. All right, so these are the rules that were given. If it's given in multiplication, you can split it as an addition of 2 logarithms. The quotient rule is if it's given to you as 1 logarithm and there's a fraction, there's a division, you can split it as a minus of 2 logarithms. The power rule said the exponent comes to the front. And we have obviously our special cases. All right, so let's use this. Let's talk about these. First of all, I'm gonna see this as 4 times x to the third. So I'm gonna split it to begin with as log base 4 of 4 plus log base 4 of x to the third. Couple of rules that I have here. On my first one, log base 4 of 4, isn't that just a 1? Plus, I have an exponent. Doesn't that just come to the front? 3 log base 4. Now for example B, let me rewrite this as log base 7 of m over n to the 1/2. 1/2 because my root, I'm going to write it as a fraction. Remember, is powered over root. So that means that I have 1/2, and then I have log base 7 of m over n. Notice how my 1/2, I just brought it all the way to the front. I'm using parentheses just because I want to emphasize that the fraction is of the log. The 1/2, I'm not going to worry about that right now. So can I just call that 1/2? I'm going to do big parentheses. Now, logarithm of a fraction, isn't that log base 7 of m minus log base 7 of n? I'm fine with that. If you guys actually want to get rid of parentheses, you want to write this as 1/2 log base 7 of m minus 1/2 log base 7 of n, because you distribute the 1/2. That's fine. Either one of those last two, it's okay. Take a look at this one. First of all, I'm just going to write this as log base 5 of a squared minus log base 5 of bc. Because I have a fraction, so I have a division. Don't I split that as a minus two logarithms? But then I want to emphasize one thing right here too. I have a multiplication. So for right now, let me just write this as log base 5 of a squared minus, in here, I'm going to write this as log base 5 of b plus log base 5 of c. Right? I split it as plus because it was multiplication. I put it inside the brackets because there's a minus before the log. I want to deal with that minus later. So that's why I put it inside the brackets. Now, I'll worry with the minus. I'll distribute it. But then when I look at my first log base 5 of a to the second, it has an exponent. So doesn't that become 2 log base 5 of a minus log base 5 of b minus log base 5 of c? Beautiful. Now, for example, D, I'm going to condense it, right? I see some minuses there. First thing I want to do is my exponent. I want us to emphasize on one thing. Notice how here, on example C, I had an exponent. I brought the exponent to the front. So if I have a number at the front, I'm going to bring it up as an exponent. I'm working things backward here. So I'm just going to write this as log base b of m to the fourth minus log base b of n. I was looking at, do I have anything in front of the logs? I'm just going to bring it up as an exponent. Now I have a minus between two logs. Doesn't that become fraction? So I have log base b of m to the fourth over n. You try some of these. And there's that one. Now looking at D though, this plus sign, right? It's not a plus in between two logs. It's a plus inside a log. We don't have a rule for that. So we can do C, but we cannot rewrite D. Right? If the plus was in between two logs, yes, we can condense it. But we cannot do a plus of a log.